We're going to look at some examples of plotting polar coordinates, and typically when we plot two-dimensional points we use a vertical axis and a horizontal axis, and we can continue to do that, but since we're going to be measuring angles and things, it would be nice to have some angles pre-measured for us. So instead of the typical XY Cartesian coordinate plane cut like this, we're going to look at the same plane with some angles included, and that would look something like this maybe. This is a polar plane, and so you could see we have all of the pi/6 angles laid out here on this plane just to help us get more accurate measurements for our points. And in fact, we'll say each of these tick marks here is one unit, so this is 1, 2, 3, 4, etc. Okay, so let's look at some examples now. If I want to plot the polar coordinates, so this has to be given in some sort of context so that when you see an ordered pair such as 1, 5 pi/6, it's understood that polar coordinates tells us that this is r and this is theta. This is how far from the origin we are. This is our angle that our point this is basically the terminal side of our hypotenuse of our reference triangle. So the first thing we'll do is, actually I like to do the theta first and then the r. Okay, I like to land on the axis here. So the first thing I'm going to do, I always like to think of theta as my axis that my point's on. So 5 pi/6 of course is over here. Okay, but what I want to think about is that whole angle gives me this as my axis. This is basically like a new x-axis or something, right? You got, it's cut right here at the origin, so one side of this is the positive axis, one side is the negative axis. Well, the side that lands on the side of 5 pi/6, which is over here, 5 pi/6, that's the positive side of the axis, and our r value is positive. So that means I'm going to land on the positive side of my axis, and I'm going to land 1 unit from that origin. So this is the point that I get in polar coordinates, the positive 5 pi/6 axis, and I'm positive 1. Let's take another look. Okay, so again, r is 3, theta is 23 pi/4, which is the same as 5 3/4 pi. So 5 pi lands over here, and I need to go another 3/4 pi. This axis does not have my 1/4 pi's cut out for me, so my 1/4 pi's, remember, like my 45-degree angles. So if I'm here and need to go 3/4 pi, here's 1/4, 2/4, 3/4. So my axis that I'm referring to this time is this axis on 3/4 pi, which extends across the origin. The positive side of this axis is where 3/4 pi lives, which is over here, and I need to be at positive 3, so 1, 2, 3 puts me right here. So that point is 3, 23 pi/4. And you may start realizing that polar coordinates are not unique, right? This could be represented as 3, negative pi/4 as well, right? Because negative pi/4 is here, and I'm 3 from the origin. Bam, I've got the same point, but that's a 4 by the way. I've got a different representation of it because the angle part of it could be any angle that's coterminal. Now is where it gets interesting when your r value is negative. So my axis is going to be at 3 pi/2, which of course is down here. So my axis extends all the way across the origin. My positive axis is in the direction of 3 pi/2, so my positive axis is down here. But my r value is -2, so I'm not going to land over here at +2, I'm going to land on the negative side of this axis up here. So this is my point for -2, 3 pi/2. You should take a look at it. This point could also be represented as 2, pi/2, right? Because then pi/2 would be the positive axis, and I'd have to use +2 here instead of -2. So your r values for different representations of the same point, if it's 2, it's got to be either positive or negative, and then you just have to land on either the positive or negative side of the axis with the given angle that you have.